Hi.
Hello, welcome back everyone. In this tutorial, I will demonstrate you how to create a CAD model and then how to convert it into a STL file, and by using STL file we will generate G code, and then we will feed this G code into 3D printer, and then I will show you how 3D printer works, and then I will inspect the 3D printed part. Okay, so first of all I will create a simple geometry, and this is the interface of SolidWorks, and first I will change our default unit, and we can change from here, and here already default unit set default unit is MKS, and from here I will choose millimeter, gram and second. Now our default unit is mm, G and S, and now we will create a simple geometry. So for this we will select a sketch, and then we will choose a sketch, and sorry, I have chosen something wrong. So we will choose a sketch, and then we can select any plane. On that plane we will create our geometry. So I am choosing top plane, and now from here I will choose a circle, and you can anytime choose perimeter, circle or line or anything you can choose. Okay, so I am choosing a circle, and now I will define its diameter. Right now I am choosing 50 mm diameter. Okay, now I will extrude this circle, and for this we have to provide extrusion length. I am using 20 mm extrusion length, and from here we will get a cylinder. Okay, to create some complexity I will make some other features on this cylinder to demonstrate you how to print. So for this I am choosing this plane, and I will make it normal to the this face. Okay, and now I will sketch on this plane. Okay, now I am choosing a circle, and I will make its diameter is equal to 2 mm. Okay, now I will choose extrude cut. From here features we can choose anything as per our requirement. Right now I am choosing extrude cut, and from here I will change extrusion length is equal to 5 mm. So now this command will remove the material up to 5 mm and of diameter 2 mm. Okay, and now I will also remove some material from this surface, this face. For this I have to click on this, and then I have to click normal too, and then I will choose sketch, and from here I am choosing a circle. Okay, and I am defining its diameter is equal to 10 mm. Now I will use extrude cut. So this will remove the material, and I am using 5 mm extrusion length. Okay, we can change it as per our requirement. So I am using now I am using 7 mm. So now I will click on this, and this will remove the material. Okay, so this is our final geometry. Now we want to import this geometry into Craftware Slicer. So for this, first of all we have to save this geometry. So from here we will save as, and we can rename it as right now I am choosing cylinder. Okay, and this is the default file format. dot part dot sld part. So I will save it on the desktop, and I will make a copy in the STL form. So, because Craftware can read only .stl. So from here I will again click on save as, and from here I will choose STL. This is the .stl. Okay, and from here option we can choose, we can define how to generate STL file. So you can see from here, when I am choosing coarse resolution, then this is a like this, and this is for fine, this is for custom. But I will suggest you to make it close to 0, and this is also close to 0. This will give you a good resolution. Now I will click on OK, and I will save it on desktop. I will rename it as cylinder 1. Okay, this is the desktop, and now I will click on save. So this file will be created in the form of triangles. Okay, so now we have both .part file and .stl file. Now to generate G code, we will import this file into Craftware Slicer, and for this we have to open Craftware. So this is the bed, and we have to place our geometry on this face, and and first of all we have to set this. Suppose this is X direction, this is Y direction, and this is G direction, and we can modify it as per our available printer. For this we will click on this option, and then I will click on printer, and then we can choose from here various types of slicer which we are using, and from here we can resize our 3D printed 3D printer bed. So from here I am changing it to 220 and 220, and Z is equal to 240. We can change it from the manual which we get along with the 3D printer. So as per my manual I have these dimensions, so I have set X, Y and G, and now I will click on OK. So this will modify the X, Y and Z. Now on this entire face we can place our object as per our requirement or as per our size, and there will be one origin. This point will be origin, and this will be the home position, and our printer's nozzle will move from here. Suppose right now I am placing our sample at this position, then our nozzle will move from here, and this will start printing like this. Okay, so for this we have to first import our geometry, or we can say that a .stl file. So we will click on this add, and then we will choose the .stl file, and we will click on open. So this is our required geometry, and one important thing is while printing, so there will be some issue of gravity while printing. So this part can be easily printed. Okay, there will be no gravity issue, but gravity issue will lead problem at this location, because when this will print this portion, then there will be requirement of some support. Okay. So suppose if we want to make this as a base, so we will click on drop, and now you can see that there is a popping arrow. So if we click on this will reverse the direction. Okay, and we can print this side because this hole is very small, so we will not require any support, but I will demonstrate you how to use support. So I am making this as a top. Okay, so I will make this as a base. Okay, now I have to click on to generate support, so I will click on support, and automatic supports only from bed. This will generate support only from bed. If we want to generate support from here, then we can't do this, so we have to check or uncheck as per our requirement. So right now I am using automatic support only from bed. Okay, and auto generate support, I will suggest you to use auto generate support because this is optimized support. So after printing, you will get less effort to remove that excess material. So now I will click on this auto generate support. Okay, so this will generate supports. Okay, you can see supports are generated. Okay, so now I will click on slice, and from here we can change various parameters. I will make a dedicated video on how these parameters affect printing later tutorials. So right now I am using extrusion width as a 0.5 mm, layer height 0.01 mm. This is a very important aspect. So uh, you have to aware while purchasing your printer. So if you want to make very small objects, so the layer height should be very small. Okay, but right now my printer has minimum printable layer height is 0.1 mm, so I am choosing 0.1 mm. This is the dry speed, and you can I will make a dedicated video later on. So right now I am using default speed, that is a 60. So if you want to see a simulation of this, so you can click on this. I have made this speed 70 mm per second. So this is the nozzle moving in this direction. Okay, as we will increase the speed of this will also increase. So right now I am using default speed, that is a 60 mm per second. These are the some default parameters. Right now I am not explaining these. Okay, and here we are using infill and micro travels. you you can always see how what is the meaning of, you can read it from here, and you can see the animation or animation from here. So right now I am using maximum density. So as you can see that as I am increasing the density, you can see the effect here. Suppose I am setting this as 50. Okay, sorry, I will demonstrate you again. If density is less, then that means these are the coarser lines, and if density is highest, then this line will be closer. Okay, and from here you can choose type of infill, and right now I am using parallel lines. You can change it to square grid. Okay, and you can change it as per your requirement. Okay, so right now I am using parallel lines. Okay, and I am choosing maximum density, that is 120, and the width of this line I am choosing 50. Okay, now I will and you can always change the temperature as per your available material. Right now I am using PLA, and you can and you can change these units by doing some literature, or you can normally the 3D printer spool that comes from market, they already give you the value of temperature and head temperature. So you can change it as from manual provided by companies that are producing PLA or ABS. So now we have to click on this slice. So this will generate G code. Okay, and you can see these are this is the generated G code, and this is the statics related to this part, and this is just showing time, required time by this specimen is 5 5 hour 44 minute and 30 second. Suppose I will feed this file to the 3D printer right now, then this will finish this job by 10:59 a.m. and this is the required filament length. And you can see travel move, Z travel move, retract prime, and required PLA ABS materials. So now I will save this file, and from here we can save this G code. This is the .g code. Okay, so we will save it on desktop, and in further steps I will show you how to feed this file into 3D printer, and then there are I will explain you various involved steps while the 3D printing, and then I will tell you inspection of this 3D printed part. Now I will show you the second step of this tutorial. In this video I will show you how to insert the G code file to the Ender 3D printer. Here we have one slot. This is the USB connector. From here we can feed our G code, and I am inserting this memory card, and from here we have to start this printer. This is the power supply. Now this will start, and this is the spool, and here I have PLA, and this will feed from here. These are the two feeders. We can control their speed, and this is the nozzle area, and here this is the interface of Ender 3D. Here you can see that there we have two temperatures. First one is the temperature of nozzle, and second one is temperature of bed. This is the bed. Okay, so we have to press on this, then these instructions will come. So we have to rotate it clockwise and anti-clockwise to choose different options. Now we have to click on print from TF, and we have already saved our G code file named cylinder G code, and now we have to press on this. So this will go to its home position, and now nozzle heating started, and simultaneous bed is also heating, and you can see that the temperature is increasing, and this will go up to 215 degree centigrade, and bed temperature we have set 60 degree centigrade. Okay, and after this heating the printer will start to print our model. So we have to wait for the temperatures to reach these limits. And this is the home position, and we can print anywhere on the bed, as I told in the while I told you the generation of G code on Craftware. So you can print anywhere on this bed. Now heating is ongoing. So meanwhile I will tell you some parts of this 3D printer. This is the power supply, and this is the bed, and this is the nozzle area. You can see that this is the nozzle tip. This is the nozzle tip. Oh yeah, this is the nozzle tip. This is the nozzle tip, and extruded filament is coming out from this, and from here we can adjust the force, and these feeders will rotate to feed this wire inside, and opposite motion will exit the wire. So So you can see that printing is started, and here you can see that progress of the your job, and this is the time, and these are the x, y and z coordinates. Heating is already done, and this is the print. You can see that printing is started. You can see that. So you can see that printing is almost going to complete, and this has taken almost 25 minutes, and the job is completed 99%, and this will stop after 100%, and then the temperature of nozzle and bed will go down, and you can see that this is automatically returning to its home position. Okay, so and now the cooling is also stopped, and you can see that temperature is decreasing. Both the temperatures, nozzle as well as bed temperature, is going to the room temperature. Okay, and this job has taken 25 minutes and 47 seconds to complete the printing of this job. And you can see that x is equal to 0, y is equal to 0, and z is equal to 11. And you can see that this is from this is 11 mm from the g barabar 0, x y and g barabar 0. So you have to you can do it to its home position. So now you have to press on this, and you have to click on this prepare and now you have to choose auto home, and you can see that this will go to its original home position. Now this is x0, y0 and z is equal to 0, and from here you have to click on main and then information screen. Suppose you want to print next part, then you can again choose print from TF, and you can choose your job from here, and you can do as I told earlier, and when your job is completed, you can simply turn down from here. Now I will show you how to remove the printed part. So for this you have to remove these clips, and this may can vary for different printer, and I am making this tutorial for Ender 3D. So you have to remove this plate. Okay, and this is a very small job, so you can easily remove it, and you can see that this is very well printed because this part was very small, and this also does not require any support because this hole was very small. So you can see that. I will also attach some microscopic image of this 3D printed part to get a better idea about its printing ability of this printer. So you can see that this is our 3D printed part, and this is a very well printed, as you can see that. And for cleaning purpose we have to use this, and by using this we can remove this excess material. So I will remove this, then I will show you final result. So I have removed the excess material, and this is the final 3D printed part. So I am measuring the dimensions of this 3D printed part by using a microscope. Usually in practical we measure all the dimensions of the 3D printed part by using coordinate measuring machine, that is also called CMM. But right now I am able to only show you this. So you can see that this is the printed hole, and I will measure this. So I am taking, from here you can set magnification. This is around 50, so this is 50, and now choose, I am choosing 3 point circle. This is not good. I will choose another circle. So from here I will choose 3 point. So I think this is the right position, and from here you can see that radius is almost 0.472 mm, and I have provided this radius is 0.5 mm, so there is a little bit error while printing, and I am also doing some error while measuring this radius. So this is, I think this is sufficient.
Goodbye.